Alright, let's go again. So, today what we're going to be doing is we're going to talk a little bit more about the laws of exponents. So today we're going to focus on the quotient of powers and what the heck we do with negative exponents. So, quotient just means division, right? It's like the answer to a division problem. So what we're going to do is we're going to take a look at some problems like these, see if we can figure out like the little shortcut rule that we're going to use for a lot of them. So first up, I've got x to the 7th over x to the 3rd. Right, so what we're going to do is we're going to keep it as division, right? Not changing anything about that yet. And x to the 7th, I'm just going to write it all out, right? 1, 2, 3, 4, 5, 6, 7. Phew, just barely enough room there. On the bottom, we had x to the 3rd. So this is x times x times x. So this is another one of the ones that we took a look at when we did our lesson on factoring, right? So you might already be a little familiar with this. What's going to happen is that when I have the same thing on the top and bottom of a fraction, right, what I can do is I can just cross off anything that's the same that we're multiplying. Oops, oh gosh, sorry about that, just zoomed way on in there. So what we can do is we can cut those x's because they match. We can cut those ones, and we can cut these ones. Right, so what we're doing here is we're then going to take a look at how many are left once we simplify that. So up top, I've just got 4 x's. Right, all multiplying each other. So I can call that x to the 4th. Cool, that's it. That's all we're doing. Right? So if you think about 7, you think about 3, right? You might already be able to kind of latch on to the idea of what it is we're doing as our shortcut for these. Right? If I've got m to the 14th over m to the 5th, right? Let's kind of think about it. If I wrote out m to the 14th, not only am I going to get a cramp in my hand, but I'm also going to run out of paper a lot. So 4, 5, 6. Let's say that this is the 14th one. Right? If I think about having 5 m's on the bottom, right? 1, 2, 3, 4, 5. Right? We think about what we were just doing, where we can cross off the ones that match on the top and bottom. What we're really doing is up top, right? I had 14 m's. We just crossed off 5 of them, right? Those 5 are now gone. So it's like we did 14 minus 5, right? So that's our little shortcut here, right? Is just to think about it like we're subtracting the exponents, right? So m to the 14th divided by m to the 5th means that, all right, m to the 14 minus 5 is 9. Right? That's what we've got left over in that yellow piece. Right? When we've got y to the 12th divided by y, right, we just think about, how many we'd have left over once we cross everything out. If we had y to the 12th on top, right, that's 12 y's all multiplying. If I cross one of those out to cancel the one on the bottom, that means that I've got 11 of them left. So y to the 11th. Right? This is another one of those properties where if you're thinking like, wow, this seems easy, what's the catch? No catch, right? That's really all we're doing is we're subtracting the exponents. Something to note that we kind of talked a little bit about last time when we were talking about the powers of products and all that, is that they have to have the same base, right? The fact that this is y and this is a y means that we can do this, right? The fact that on A we had a couple of x's that matched meant that we could do this. If I had like mixed variables or something like that, right, I can only cancel them out with other ones that are the same. Okay. This last one here is a little bit weird. We have n to the 13th over n to the 13th, right? So you might be thinking like, why is that weird, right? 13 minus 13, cool, it's 0. Right? But we didn't really talk about what anything to the 0 power was last time we ran into it. So let's think about just this fraction real quick, right? Imagine that we didn't do that the rest of the problem now. If I have something divided by itself, right? Like if I have 4 divided by 4, that equals 1. If I have 17 divided by 17, it equals 1. All right, so when we get n to the 0 here, that's also going to be equal to 1 because it's something divided by itself. All right? So this is actually one of the properties that we're going to list out a little bit later more formally, right? But just something to plant in your head real quick. Right? But for right now, our quotient of powers property is what we're focused on. Alright, so the quotient of powers property is going to look something like this, right? If I have a to the m, and I divide it by a to the n, right? Again, we need to make sure that they have the same base, right? They both have a, so we can do this property. What I'm going to be doing is I'm going to be doing a to the m minus n. Right? It's the top minus the bottom. Right? That's really all there is to it. Oh boy. Mr. Pog, what are you doing? That doesn't look like the property you just put. So there is a little bit more to some of these problems. But it's not going to be too bad. Right? So kind of like how we approached multiplying with all these different types of things, we're going to approach division the same way. What I'm going to do is I'm just going to take the pieces that divide together. Right? So for example, 30 divided by 5 is going to be 6. Oops, maybe. There we go. Cool. That part's done. If we take a look at the x's, we had x to the third divided by x squared. Right? So 3 minus 2 is just one of those. So I could put x to the first. Right? A lot of times you won't see that first power on there. Right? So most of the time your answer, whoops, will just look something like that. That's okay, right? There's nothing wrong with that. That's actually how you're going to see it more often. If it makes you feel a little bit better to have that 1 on there, there's nothing wrong with it. Right? It is there, it's just invisible a lot of the time. Last but not least, right, what we got to do is we got to take a look at the y's. We had 6 up top, we had 1 on the bottom, so when we do that division, 6 minus the 1 gives me 5 of those left over. Right? So 6x y to the 5th. Cool, that's it. Right? We're just taking them one piece at a time and dividing just those. Right? Same kind of deal on this one. I'm going to divide the pieces that go together. Right, so 40, divided by 8 is going to give me 5. That stuff that's highlighted in yellow. When I'm taking a look at the b's, I had b to the 10th, and then there's 1 on the bottom. So if I had 10 and I took 1 out by dividing it, I have 9 left over. Last but not least, I've got c to the third, and then a c squared on the bottom. So what I'm going to do is I'm just going to have 1 left over. And again, that 1 is optional. Most of the time you won't see it, but if you want to put it there, it's not going to hurt. Right? Cool. That's all there is to that. Right? If you haven't paused and tried one on your own yet, this is not a bad one to do. Right? We've got 49x to the 7th y squared divided by 7x to the 4th. Right? So again, taking the pieces that go together. 49 divided by 7 is 7. Right? We've got x to the 7th divided by x to the 4th. So when I go ahead and subtract those exponents, it's going to be x to the 3rd. Right? Last but not least, we've got a y squared. And we didn't divide it by anything, right? So that's okay. We just bring it along, right? Nothing changed. This is y squared. Okay. Really all there is to this, right? Another way that you could do these problems out, right? And you don't have to do it this second way that I'm going to write it just now, but if it kind of helps you organize your thoughts a little better, that's perfectly fine. You could take this starting problem and you could write it out as 3 separate little pieces. You could do 49 divided by 7 times x to the 7th divided by x to the 4th times y squared over just 1, right? Because there's nothing going on there. And you could do the same thing out, right? This stuff for 49 divided by 7 will spit you out there. That'll spit you out there, and that'll spit you out there, right? So you get the same answer, right? Depends on which way you like to do it. Either one is going to be all right. Yeah. Oh boy. Oh no. Oh gosh. This looks gross. So what we're going to do is we're going to try and figure out what the heck is going on when we have negative exponents. So let's start off with just this first piece here. I've got 2 to all these different powers. So let's start off with a couple easy ones we can fill in, right? 2 to the first power is just a 2. 2 squared is 4. 2 to the third is 8. 2 to the fourth is 16. Right? So what I'm trying to think about is like, all right, what's going on as I go down in powers, right? So I went from 16 to 8. What happened is it's like I divided by 2. To go from 8 to 4, again, it's like I divided by 2. I divided by 2 again. Right? So that stands to reason that when I go down to here, I'm going to take that 2, divide it by 2, and get 1. Right? So far, everything seems to be kind of following the same pattern. Right? When I go one step further, right, now I'm going into a negative exponent. Right? It's going to follow the same pattern. So what I'm going to do is I'm going to take 1 and I'm going to split it in half. So half of 1 is just 1/2. Right? If I think about a half and I need to split that half in half, all of a sudden I've got a quarter. Right? If I've got a quarter and I'm splitting that in half, all of a sudden I've got an eighth. It's like I'm dividing by 2 over and over and over again as I go down in the powers. So when we have things to a negative power, right, sometimes we might end up with fractions, right? It's going to kind of spit itself into being a fraction. Right? But what's really going on is kind of interesting for these. So just for these negative powers, right, 1/2 is the same thing as 1 over 2 to the first power. Right? 1/4 is the same thing as 1 over 2 squared. And then 1/8 is the same thing as 1 over 2 to the third. Right? So what we can do is we can actually take those powers that we were working on a little bit ago, right? 2 to the first is equal to 2. 2 squared is equal to 4. 2 to the third is equal to 8. And we can rewrite it in those ways that I have on there in red. And so whenever we have a negative exponent, right, it's kind of doing a little bit of jumping around with a fraction and stuff. Right? Let's try it out with some 3's. Right? So yeah, we can do some easy ones that are, not too bad. 3 squared is 9. 3 to the first is 3. 3 to the third is 27. And 27 times 3 will give us 81 for that fourth power. Right? So on this one, if I'm kind of thinking about what the pattern is, I'm dividing by 3 every time I go down. Right? So when we were having powers of 2, we divided by 2 every time. When we're dividing by 3, or when we have powers of 3, we're dividing by 3 every time. Right? So as I'm trying to fill in the rest of this, I'm going to be dividing by 3 to get that next line. So 3 to the 0, right? This is 3 divided by 3 is 1. So then if I have 1, and I divide it by 3, right, I get 1/3. If I take 1/3 and I divide it into thirds, right, if I divide it by 3 again, I get 1/9. If I take 1/9 and I divide it by 3 again, I get 1/27. Ew. See, this kind of sucks. I don't really want to have to figure all these out this way. Right? If I went 3 to the negative fourth, that's going to be 1 over 81. If I wanted to figure out what 3 to the negative fifth was, I got to divide by 3 again, and it's 1 over, 243. If I want to get 3 to the negative sixth, I have to go 1 over, oh gosh, what's that even going to be? 607.29? Oof, that sucks. I don't want to do that. So that's why we kind of have this little rule to help us out. Right, so just like we did with the powers of 2, I can represent these negative ones a little bit differently. 1/3 is 1 over 3 to the first. 1/9 is the same thing as 1 over 3 squared. 1/27 is the same as 1 over 3 to the third. Right, so this makes our lives quite a bit easier than having to try and then keep going and figuring out what these things are. Right? I can just leave it as 1 over 3 to the third. So when I was kind of stumbling on that one where it's like, oh, 3 to the negative sixth, I don't really care what it is, right? I can just rewrite it as 1 over 3 to the sixth and say like, boom, gotcha, it's done. All right, sweet, let's move along. Right? So these exponent laws can help us write out some pretty big numbers in some pretty nice ways. Right? So we don't have to write out like 18,000 zeros on some stuff. So we've got a couple properties when we're dealing with negative exponents. Right? The first one is kind of the one we were just working on. If I have a to the negative m power, what happens, oops, I don't know why we changed colors there. What happens is that we kind of flip it into a fraction. We put that a on the bottom, and then that power becomes positive. Right? So you can kind of see that we did that with that 2 to the negative third at the top of the screen there. We had 2 to the negative third. We kind of flipped it into a fraction. We put that 2 on the bottom, and we changed that negative 3 into a positive 3 for the power. And what this is basically doing is it's kind of sort of like taking the reciprocal Reciprocal just means that you're like flipping a fraction on its head, right? Because a to the negative m is the same thing as a to the negative m over 1. Right? You can always divide something by 1 and it'll be itself. Right? I get a little bit deeper into it than we kind of need to right at this second. Right? But sometimes we might end up with problems like these ones. Right? So another property that we can use for negative exponents is one that looks like these. If I have a divided by b, like that whole division problem, in parentheses to a negative power, what I then want to do is I want to flip it over and change the power to a positive. All right. So that's all we really got to do with that, right? If you flip the fraction, then you get to change that from a negative exponent to a positive exponent. All right. We've also got this zero exponent property that I kind of teased in front of you at the beginning of all this. If I have a to the 0 power, right, it's just going to equal 1. Anything to the 0 power is going to equal 1. If I wanted to figure out what 17,635 to the 0 power was, it's just 1. Cool, that's all there is to the zero exponent property. So anytime you got something raised to a 0, it's just equal to 1. Okay. So what we're going to do is we're going to practice a little bit about rewriting things that they don't have negative exponents, right? Because negative exponents are kind of gross. If we can write things out in like a fraction-y way without the negative exponents, that's what we're looking for. So this first piece here, right, we've got a to the 7th times b to the negative 4th. So this b to the negative 4th is the piece that's kind of messing with us right here. Right? B to the negative 4th, right, we know is the same thing as 1 over b to the positive 4th, right? Just using those properties that we were just talking about. So now what I've got is I've got a to the 7th. Right? If I can write it down here and kind of pretend that this one doesn't exist anymore. So I've got a to the 7th times 1 over b to the 4th. What happens is that a to the 7th kind of kicks itself up on the top. Right? So our final answer for a problem like this would look like this. A to the 7th divided by b to the 4th. Right? If we kind of take a look at another one where it's c to the negative 8th times d squared. Right? Let's kind of talk about different ways we can write out these as fractions. So c to the negative 8th, again, is kind of the same thing as 1 over c to the positive 8th. Right? We're just kind of rewriting that to get rid of the negative exponent. Right? Another way to think about d squared, we could think about it as d squared over 1. Right? So I don't know if you remember back to algebra 1a. Right? Anytime you were working with like a slope, right? Say you had a problem and it was like y equals 3x plus 5. You've got your slope here. And what you've always thought about it is right, it's 3 over 1. It gives you kind of like a rise and a run that you can use. Right? It's kind of sort of the same idea by putting this 1 underneath d squared. Right? Anything divided by a 1 is going to be itself, so we can put that divided by 1 there. Okay? To help out with the multiplying by fractions, right, the top multiplies the top. So 1 times d squared is just d squared. Right? The bottom of a fraction multiplies everything else on the bottom of another fraction when you're multiplying. So it's just going to stay c to the 8th. Okay? So, this is more steps than you really need to do for these. Right? I'm trying to do my best to explain it in a way that hopefully kind of makes sense when you guys are doing these on your own at home. Let me know how I'm doing. Right? But there are a couple different ways that you can think through these types of problems with exponents and how to handle them. Oh my gosh, yuck. So whenever you're faced with something kind of gross like this is where the shortcuts kind of come in handy. So the shortcut I'm going to kind of give to you, right? You could do them out just like the last two we did. There's nothing wrong with that. What I'm going to do is I'm going to say, all right, I'm going to look at these ones that have negative exponents. Right? Anything with a negative exponent seems like it's been ending up on the bottom of a fraction. So let's put out a fraction. Let's just put those there now. Right? X to the negative 4th is going to go on the bottom. We change the exponent to positive 4. The y is going to go to the bottom. We're going to change that exponent to a positive 3. Right? Anything else that had a positive exponent seems like it's been ending up on the top of the fraction. Right? So let's just put them there. W squared stays up top. Z to the 7th stays up top. Cool. Done. That's it. Right? Hopefully seems quite a bit better than writing out everything as a fraction and kind of smushing them together. If you still want to do it that way, there's nothing wrong with that, right? Especially as we're learning them. Do what makes you happy. Right? So then we run into some of the ones like these, right, where we have the fractions kind of going on. So nice and simple, right? Just like the property we had up above. I flip the fraction over, so instead of 5 over 4, it's 4 over 5. And then I change that exponent to a positive. Right? Something we can do, right, and we'll talk a little bit more about this when we get into the thick of things a little better, is that if I have, this exponent on the outside, if I'm kind of squaring this whole thing, it's 4/5 times 4/5. We can actually figure out what that is. Right? So if I did 4/5 times another 4/5, right, the tops multiply together, the bottoms multiply together. We get 16 25ths. Right? For right now, if you can get to this piece right here, that's awesome. Right? That's really what we're looking for. We're trying to use the properties. If you're able to get all the way to there, then that's super extra excellent awesome. Right? That's really where we're going to be trying to go with these, is simplifying things as much as possible. Right? If I've got 3/2 to the -4th, right, again, start off the same way. We had 3 over 2. I don't think so. Now it's 2 over 3. And then we change that from a -4 to a +4 for that exponent. Right? It's the same thing, right? I could do 2/3 times 2/3 times all that 4 times. What I'm going to end up with is 16 81sts. Yuck. Gross. Ew. Right? Again, if you can get to this part right here, that's perfectly fine. That's what we're doing. We're using the properties. If you're able to then do out the rest of the math and get to 16 over 81, awesome. Right? That's perfect. Okay. Oh boy. Oh gee. It's kind of the same thing, except now there's variables. Why would you do this? It's not going to be that bad. Right? 1 over m squared to the -3rd. Start off the same way. Flip that fraction. M squared over 1. Change that to a +3. So something I was doing a little bit ago, right? I was saying that anything divided by 1 is just that thing. So this is really m squared to the 3rd power. Right? We don't really need the divided by 1. Right? We can use it as a tool, right? It can help us figure things out a little bit better. But at the end of the day, you don't really need it there. So then m squared to the 3rd power is m to the 6th. Cool. This is where we want to get to on these ones, right? Whenever we have just exponents on variables, and we're not trying to do any sort of things with like simplifying numbers and all that, we want to go as far as we can. Yeah. For the second one over here, same kind of idea from the start. I have 1 over k to the 4th, so I'm going to flip it upside down. K to the 4th over 1. That changes that -5 to a +5. After that, this is just k to the 4th on the inside of those parentheses, right? Just like we talked about. We don't really need the divided by 1. Right? And then using the properties we learned about earlier, right? On our last video lesson, 4 times 5 gives me 20, so k to the 20th is what we're going to get out of that. Okay. Again, I'm hoping that these ones don't seem so bad, right? If you take them one step at a time, that's really the best advice I can give you. Don't try and rush straight to an answer right from the start. If you feel like you're kind of getting there, the more problems of these you do, take the shortcuts, right? As long as you come out with the right thing, I probably won't even know, right? But as we're learning them, if you need to take it one step at a time, do that. There's nothing wrong with that. Okay. Holy moly. Oh, gee, why would we do this? Right? This is not as bad as it looks. Right, I know that's hard to think about. So what I'm going to do is I'm going to pick the pieces that match. Right? Kind of like what we were doing towards the start of this. Right? Is that I'm finding out all of these different pieces that we are going to divide together. So when I've got all of these different fractions going on, right? All these different pieces that I want to divide, I'm actually going to try and take them one piece at a time. Right? So 5 divided by 15, right, is the piece in yellow. I'm going to split it up like this. We got a to the 4th over a to the 11th as the second piece. We got b to the 7th over b to the 5th as the third piece. you got c squared over c to the third is that last piece. Right? So what we're going to do is I'm going to take it one piece at a time, right? 5 over 15. Doesn't come out as some nice whole number, right? But I can still simplify that fraction, right? 5/15. It's the same thing as 1/3. Okay? If I had a to the 4th divided by a to the 11th, what I'm doing is I'm subtracting those exponents, right? 4 minus 11 gives me -7. When I have b to the 7th divided by b to the 5th, 7 minus 5 leaves me with 2 of those. Last but not least, c squared divided by c to the 3rd, right? 2 minus 3 gives me -1. Right, so now what we've got is we've got this new problem down here, right? 1/3 times a to the -7th times b squared times c to the -1st. Turns into one of the problems that we were doing a little bit ago. Right? So actually, let me see how I can best. How about this? We have the power. Wow, would you look at that? That was super cool. I hope that you're all sitting at home staring at your computer screens and clapping because that was so sweet. Right? So this is our new problem, right? We've kind of simplified and we've gotten to this point here. So, doing that little shortcut way that I was just finishing off some of these earlier problems with, right? Like this c over here. Right? Anything that had a negative exponent seems like it ended up on the bottom of the fraction. Anything with a positive exponent ended up on the top. So we can do kind of the same deal here. Right? We had 1/3, right? So we're not going to be able to get around that, right? We're going to have a 1 up top and a 3 on the bottom, right? That takes care of the 1/3. That a to the -7th has that negative exponent, right? So what we're going to do is we're going to put that on the bottom, turn that into a +7. That's nice. B squared has a +2 as its exponent. So what that means is I'm going to put that b squared up top. Last but not least, that c has a -1 on it, so it's going to go on the bottom. It's going to become a +1. Right? So this answer, is a little bit messy, right? There are a couple things that we might not normally write. If you can get to this answer, perfectly fine, right? You got just the right idea. Right? But a lot of times, we're not going to see the 1 in front of the b squared. And on the bottom, we're not going to see that 1 on the c. Right? So what we really want to try and do is get more used to writing out our answer like that. Right? If you need to take the extra step like I just did to kind of like clean your answer up at the end, not a bad thing, right? That's okay. Right? But all we're really doing is we're just taking this one step at a time, right? So we started off with 5 a to the 4th, b to the 7th, c squared divided by 15, a to the 11th, b to the 5th, c to the 3rd. And it seemed impossible. It's like, holy crap, how are we going to do that? Right? But we broke it up, and then we took each little chunk of it, simplified it as much as we could, and then used the properties that we were learning about earlier today. Right? Hopefully it doesn't seem super duper bad. Right? Let's try another one. Hooray! Alright, so again, same deal. I'm going to go through, and I'm just going to make sure that I'm grabbing the pieces that go together. Right? On this one, I'm going to kind of skip over a little step here. Right? If you want to, I'm not going to skip over it. Let's just go for it. Alright, so the first part is 3 divided by 12. Alright, after that, x squared over x to the 4th. Alright, so everything has its own little fraction here. Sorry that the highlighter colors don't match the colors that I'm writing things in. Alright, some of the highlighter colors don't come out super nice. Alright, so this is what we've got. Alright, all I did was I took this problem that we started off with and I broke it up into those 4 different colored chunks. Then what I'm going to do, with this problem is the same thing we did on the last one. Right? I'm going to take it one piece at a time. 3 divided by 12 isn't going to come out very nice, but I know that it can come out to just be 1/4. In the blue, x squared divided by x to the 4th, 2 minus 4 is -2. Y divided by y to the 3rd, right? This is technically y to the 1st up top, so 1 minus 3 also gives us -2. And then z to the 6th divided by z to the 6th is z to the 0. Right? So again, we broke it up into those chunks. We then simplified all those chunks, and this is where we're at. So again, anything that has a negative exponent ends up on the bottom. Anything with a positive exponent ends up on the top. So what we've kind of got going on here, right, is that we've got this 1 and this 4, right? Those can kind of go where they're supposed to go. We've got x squared on the bottom when we take care of the stuff in blue. The y is going to have a positive 2 when we flip it to the bottom there. And then there's that z to the 0, right? So we know that anything to the 0 power is 1, right? You're trying to think about, like, is 0 positive or negative? Let's call it positive. Let's put z to the 0 up top there. Right? So whenever I've got something that looks like this, right, again, we can kind of clean up our answer at the very end of this. Right? We don't normally see that 1 there. Right? Z to the 0, we were just talking about, just comes out as 1. So the only thing on the top of this one is just 1. Everything else on the bottom, nothing really fancy down there, it just stays the same. Right, so this is really where we want to get to on this one. Okay. Oh boy, we're almost there. Right. Oh gosh, ew. So what I'm going to do is I'm going to start by just chunking it out like we did on the last couple. Alright, so I've got 81 divided by 45. I'm going to have x to the negative 4 divided by x to the 3rd. I'm going to have y to the 6th divided by y to the negative 2. And then I'm going to have z to the 9th divided by z to the negative 3. Right? So again, as we go through these, I'm just going to take it one step at a time. If I have 81 divided by 45, right, if I'm thinking about how I can reduce that, I can divide them both by 9. So what I can do is I can turn 81 over 45 into 9 divided by 5. As for the stuff in blue, if I had x to the negative 4th divided by x to the 3rd, it's like I'm doing negative 4 minus another 3, which brings me to negative 7. Same kind of deal with the yellow, orange. We had y to the 6th divided by y to the negative 2. So that's like 6 minus negative 2. Right? And we know that turns into a plus. Right? So it's actually going to be y to the positive 8. And as for the z, kind of the same thing. This is 9 minus negative 3. So 9 plus 3 is going to give me 12 z's, z to the 12th. And so it's worth being a little careful when you're doing that subtraction, right? If you want to write it out on the bottom, just like I did with those last couple, nothing wrong with that. So now we're here. Taking it that last step to get to the finish line, I've got this big fraction, and I'm going to have a 9 on the top and a 5 on the bottom. Right? So the numbers, are still doing their own thing. Right? As for the variables, anything that had a negative exponent, like that x, is going to go onto the bottom and get its exponent flipped to the opposite thing, right? So it was negative 7, now it's a positive 7. Anything that had a positive exponent, like the y to the 8th and the z to the 12th, are just going to go on the top. Cool. So we'll do one quick little check over, make sure that there's nothing that needs to move around. I don't see anything. Zoop. That's it. Done. Right. So again, I'm hoping that these seem a little bit easier as we kind of go through them, right? Split it up into chunks. Take care of those chunks one piece at a time to get to this little middle step here. And then last but not least, throw it all together into one big fraction to finish it off. All right, let's try this last one here. Oh my gosh. Ew. Gross. So I don't know if you guys noticed this, right? But there's actually some multiplication going on in this one. So what we're going to want to do whenever we're faced with a situation like this is we're going to want to take care of this before we even worry about the dividing piece. Right? So I'm just going to do that. I'm going to give myself a fraction. This 4a to the 4th, b to the 4th is going to stay on the bottom because we're not touching that yet. What I'm going to do is I'm going to take the stuff that's highlighted, I'm going to multiply that. So when we're taking a look at the stuff on the top, we've got this 4 that multiplies with this other 4. So that's going to give us 16. All right, cool. That part's done. We had a to the negative 1st times a to the 4th. All right, so again, now we're kind of mixing properties between lessons. Right? The last lesson that we took a look at, we had a to the negative 1st times a to the 4th, means that we would be adding those exponents together. And so negative 1 plus 4 It's going to bring me up to a to the positive third. All right. Last but not least, we've got b times b to the negative fourth. All right, so remember that b has a 1 on it. 1 plus negative 4 is going to bring us down to negative 3 for those b's. Okay. So again, all I did was I just took care of that multiplying on the top, and now I'm good to do the division here. Right? When I'm doing out the division, I can do it the same way we've been doing it on the last couple. Right? I can do 16 divided by 4. I can do a to the third divided by a to the fourth. I can do b to the negative third divided by b to the fourth. Okay. Taking it one piece at a time from here on out. 16 divided by 4 is just 4. a to the third divided by a to the fourth is going to land me with a to the negative first. B to the negative third divided by b to the fourth is going to land me down at b to the negative seventh. Right. One last little step is that anything that has a positive exponent stays on the top. Anything that has a negative exponent goes to the bottom. All right, so we do have some stuff with negative exponents. I'm going to put a to the first down there. I'm going to put b to the seventh down there. Right, remembering to flip those to be positive exponents when we put them on the bottom. And then there's that 4. Right? So trying to figure out where that 4 goes is something that I see people make quite a few mistakes on. Right? That 4 is really 4 to the first power. Right? It's a positive power. So what we're going to do is we're just going to pop 4 up top. Cool. Right? That's really all we need to get to. Right? If we really wanted to be fancy, we would get rid of that little 1 over the a. Whoops, not the whole b as well. Right? Just that little piece. And if we get to there, that's really what we want. If you leave the 1 in there, it's not the end of the world. Alright, so please be sure to check in Google Classroom for anything else that you got to do. And I am out of here.